So we've spoken about strong and weak acids and bases. Let's actually now define our acids and bases, right? So the first definition is going to be the Arrhenius definition. And the Arrhenius definition has this particular limitation. And the limitation is that, well, it only applies to putting something in water. So if you've got an acid or a base or something that you want to define as an acid or a base, it has to be water soluble, for example, in order for you to be able to go and say, well, is it an acid or is it a base? Which is a bit of a limitation, right? But Arrhenius theory says that an acid is something that you place in water, and when you do, it ionizes to form hydronium ions, right? And then a base is something that you put in water, and then it is going to dissociate in order to form hydroxide ions. Then we've got the Bronsted-Lowry or the Lowry-Bronsted, and this is going to define an acid or base in terms of donating or accepting a proton. So it's going to say that an acid is a proton donor and then a base is a proton acceptor. Now, something strange that you might notice here is that when we say proton, we actually mean hydrogen ion, right? As if hydrogen ion and proton are interchangeable terms that actually refer to the same thing. Now, is this possible? Why on earth is this the case? Well, let's think about the hydrogen atom, right? So if you go to the periodic table and you look at the hydrogen atom, you'll see it's numero 1. It is going to have a mass number of 1. So that mass number of 1 means that there is only one mass particle in the nucleus, and that's going to be, well, a proton, right? Because hydrogen has to have one proton because it's got an atomic number of 1. So that then means that elemental hydrogen that has not yet ionized in any way has a proton in the nucleus and nothing else, and then that single electron that will be orbiting that proton in the first energy level. Well, if we ionize, it means we either gain or lose electrons, and in the case of forming a positive hydrogen ion, well, that means that we lose this electron. Now, if that electron has been lost or donated to something else, well, what's left is simply that single proton that was the nucleus of the hydrogen ion. And so, when we say hydrogen ion and we say proton, it's actually the same thing for this very reason. Okay, right, so then here you can actually see both definitions in action, right? Because here we've got HCl, and the HCl donates its proton to water in order to form the hydronium ion, right? So there the HCl is acting as a proton donor and thus is an acid, right? However, it's also forming a hydronium ion, and so in terms of the Arrhenius theory, we can also label it as an acid. Then if you go look at this ammonia here, the ammonia is going to accept a proton from the water, and a proton acceptor is a base. And so according to Lowry-Bronsted or Bronsted-Lowry, the ammonia here, the NH3, is in fact a base because it accepted a proton. Now Arrhenius would say, well, actually this forms a hydroxide ion in water, and so it is going to be a base. So there the two things agree.